Hello everyone, my name is Morteza Bashsiz. I am a Linux system engineer. At this series of videos, you are going to find out how to be a good Linux system engineer. So if you want to know, stay with me. Welcome to LSE episode 10. This is the last episode from Concepts chapter, and at this episode I am going to talk about some main and important metrics that you should know as a Linux system engineer. So let's start it. So at this episode I am going to talk about these topics, the metrics that are important when you want to evaluate your operating system, your resource usage, and when you want to talk about your performance. It's important to know about them, and when you hear some metrics to describe something in operating system or over network, it is important that you completely understand that what is the metric and how to define it and what is important to know about it. The first metric is utilization, and it defines how much the resource is busy or used. For example, for memory, for RAM, imagine that I have 100 gigabyte of memory, and from this amount, about 70 gigabyte is in use by operating system. So we could say that this memory, the memory is utilized by 70 gigabytes. That means the operating system and all the process inside the operating system are using 70 gigabytes of my memory. So this is utilization for memory. And the same about CPU. For example, when your processor is busy up to 45%, then you can say that my CPU is utilized by 45%. Or in another example, you can specify and separate the utilization by your process. For example, you can say that I have a process like Nginx and it utilized the CPU by, for example, 25%. And yeah, when you want to run your FTP service, it will utilize your CPU by, for example, 7% and your memory by, for example, 38 gigabytes. So when you are talking about utilization, exactly you are talking about how much the resource is in use by process, by operating system, by all the processes and by everything. You are talking about how much the resource is in use. Now I want to show you some examples in operating system. Here in my terminal I have htop command. Don't worry about what is this command. We will talk about it later. But at this moment I want just to show you some examples about utilization to understand it better. For example, here I have utilized my memory about 5 gigabytes and my swap space is about 800 megabytes, and also yeah, you can see that how much my CPU are utilized by percentage. For example, I have a simple screen recorder process, which is the recorder of my desktop that I am using, and it utilized the CPU by about, yeah, you can see that from 35 to 40%, and about 5% of my memory is utilized by this process, And also we can say another command. The other command that I can use is, for example, ser command that will show you that it's just an example. Don't worry about what is it and what are these details. We will talk about them. But just an example, you can see that all of my CPUs are utilized by 4%. And back to slides. So we now can understand what is utilization. The next metric is load. Concept of load is a little bit different than utilization. Load exactly refers to the amount of operations which are waiting for the resource at the moment. Imagine that we have a queue of operations, and this is our CPU, our resource, and they want to take the CPU and do what they want, and then they are done with the resource. Okay, so the load is exactly the queue of, at this case, load is exactly the queue of operations that are waiting to get the resource, the CPU. Imagine that your CPU is utilized by 35% and the load of your CPU is high. Then you could say, okay, maybe we have a performance issue on this operating system. Your CPU is not utilized too much, it's about just 35%, but your load is high. Yeah, it's not correct. It's not, something here is wrong. So in a simple sentence, load is amount of queued operation which are waiting for a resource. So the queue and resource. This is the definition of load. Next metric is Iops, which is input-output operations per second. And it exactly refers the rate of data transfer operations per second. For example, in case of disk Iops, it refers to measurement of read and write operations per second on your disk. So just an example, imagine that we have a disk and also our CPU is here, and we have a stream of data that we want to write it on a disk. And you see that the number of Iops for this disk is, for example, I don't know, 15. Just an example. It means that we have 15 read and write operations per second on this disk. And just another example in my command line that you can see, for 5 seconds with interval of 1 second, that you can see that how much my disk is busy, my block device. And I have at this example, at this row, you can see that I have 87 transactions per second, and all of them are write. So I don't have anything to read from disk. And at this example, I just use write operations on my disk. And now I am going to show you another example to make some load and Iops on my disk and see how the metrics are changing. And and I open another terminal here, make it always on top, and log in as a sudo, and also run the ser command and make it more readable, all data in one column. Okay, it's better now. And yeah, here I'm going to make a file with dd command, for example, with size of 5 gigabytes. Input file is dev random, and output file, for example, my home directory, test.src, and the block size, for example, 100 megabyte, and the count, yeah, if I want to make 5 gigabyte, then the count should be 50. Yeah, 50 with 100 megabyte is 5000 megabyte and 5 gigabytes. Then after running this command, you can see that how my disk will be busy and how the metrics will be increased. Pay attention to this column: transaction per second, read and write transaction per second. Okay, and you can see that yeah, mostly this is write transaction per second that is increasing, and this is because my input file is random, which is not real, and it generates randomly, and it's not on disk. Now I want to run another command. At this case, I want to put the generated, before that, if you see this file, that it is about 4.9 gigabyte of data, and I want to run the same command with input file. Now is the test src that we generated from random, and the output file is another file on the disk. Okay, and I remove these metrics from here because I have my file, and you can see that how these numbers are increasing. Here you go. Yeah, this is so slow, and because I didn't specify my metrics here, my input, and it is going to read and write, read from this and write to this. And you see that beside the read transaction, my write transactions are increased too. I mean both of them, because the input file is from disk, and I'm going to run it with, for example, another file, block size 1000 megabyte, and yeah, let's run it with 1000 megabyte of, or 1 gigabyte, it's better. Then here we go, that you can see the numbers are increasing, and yeah, this is the load, and here you can see the difference. With block size of 1 gigabyte, I execute this command in 7 seconds, and in previous case it executed with 32 seconds. It's not only because that I put the block size 1 gigabyte. If I execute it without anything, you can see that yeah, the numbers are increasing, and again this test is running, and we will wait to the results. Okay, you can see that how many transactions are on my disk, and okay, it's time. You see that the it take about 34 seconds, and I mean it's not only because this parameter that I put as input. If I I mean it depends on many things on your operating system that we will investigate it. But now for this time, just pay attention that how these numbers increased, and it was an example just for better understanding that what is utilization. The next metric is throughput. It refers to amount of data rate. Usually it defines with size per time, unit size per unit time. For example, if you remember in previous episodes, we were talked about the throughput of your network interface controller and the maximum bandwidth of your network interface controller, which was, for example, in 10G case, it means that your network interface controller can handle 10 gigabits per second. It is an example of throughput. For example, you have another network interface controller which is 1 gigabits per second. So when you have a metric that it defines by size per time, for example, petabyte per minute, or whatever, it doesn't matter. You are talking about the throughput. And what is bandwidth? Bandwidth is the throughput on network side. Exactly. When you are talking about the throughput on your network interface controller, the throughput on your network, the throughput on your switch, on your router, every throughput related to network is bandwidth. So the bandwidth of your network is, for example, 40 gigabit per second. Okay, this is the maximum bandwidth of your network, and your interface controller is using, for example, 7.3 gigabits per second at the moment. Okay, and this is the used bandwidth, utilized bandwidth. Okay, and yeah, this is the definition of throughput and bandwidth. The next metric is response time and latency. They are different. Response time is the time that operation is born till it's completed. It calls response time. Response time includes all the time that operating is executing, waiting, serving, and the others. The response time usually defines from client side, which wants some service from server. Imagine this is time, and here is 0 point of time. We have nothing here, no process. Process is born. For example, P1, and this is a simple HTTP request, for example. It generates a packet and sends to the server. So the process, the operation is born here, and then sends to server. This amount, for example, 0.3 millisecond for processing, and then, for example, for 0.4 millisecond for generating response, and 0.1 millisecond sending response to the client, and here is, for example, done. Here we are done. So all the time from here to here is called response time. So and here, for example, client sends a request to server process the request and sends the response, and here the time from sending request to receiving response is response time. And what about latency? Latency is the time that an operation is waiting for a service. It's called latency. This metric is one of the most important metrics when we are talking about performance. Latency is really important. In our example, latency could be like this. Imagine that we have node A, which is in, for example, Europe, and another node B is in USA, for example, and latency is the time that takes a packet sends from A and received to B, I mean. For example, here packet generates and sent in, for example, this time, I mean, and it received at this time, for example. So the latency of this connection and these two networks are 1 second. It's just an example. Now I want to show you the latency with an example. For latency, a simple ping command could be enough. For example, if I ping quad 1 IP, then you can see that the time is about, for example, 22, 23 milliseconds. It means that the latency between me, my IP, my host, and the destination IP is about 23 milliseconds. Okay. And if you want to see that what is the route between me and this destination, the MTR could be good tool. Don't worry about them. I want just to give a better feeling that's what I am talking about with using these commands. I will talk more about these commands in next episodes. It's just about the concepts. Okay, so when I run the MTR for this destination, you can see that how many hubs are between us, and yeah, these are the hubs. So my packet generates here and sends to the destination, and you can see that there is about 10 hubs, and it takes about 23 milliseconds from here to here. And to show the response time with another example, I have a curl format txt that I defined some metrics here, and I want to use this format to curling, for example, https google.com, and yeah, I run it, and you can see that at this time, from 0 to this time, it took about to resolve the name and the others, and this total time is my total response time. And for example, for Yahoo, you can see that there is no redirection in Google and Yahoo. And for example, if I change my domain to something else that I am sure that there is some redirections, you can see that yeah, it will take more time. And how much is it more? And time to redirection is about near 1 second. And again, don't worry about these commands. We will talk about them a lot later in next episodes when we want to check the performance of our system. And yeah, we are done for response time and latency. And our next metric is workload. Workload is the measurement of input operations for a service, for a system, for a device, and everything. I mean, it's not specific for anything. It could be different things, several things. For example, when you are talking about a web service, and you have a web service here, and you have some clients, and each client is sending 5 requests per second to our web service, and yeah, you have 4 clients, so you have, for example, you have 5 clients, then you have 25 requests per second as a workload on your web service. Or for example, when you are talking about disk, Iops could be workload of your disk, or when you are talking about your network interface controller, the throughput of your network and bandwidth of the bandwidth of your network could be the workload for your network and the other. So the workload is measurement of input operations for something. And the next metric is cache. Cache refers to a middle storage which usually is smaller but absolutely faster than main storage. And it could be on everything. I mean, imagine that you have a storage. For example, you have your disk, and this is a hard disk, a physical disk, and this is about 250 gigabytes, and here you have a middle storage, a smaller storage, for example about 350 megabytes. It's not too much. It's just an example, okay? And this is your cache. This is your cache storage. It is absolutely faster than your main storage, and but smaller, and it helps to improve the performance of your main storage. Okay. Or imagine that you have a web server here, and you have some pictures on your storage, on your disk, and you are serving these pictures to clients, and for increasing your performance you fetch these pictures to your main memory because it is more faster than your disk. And also when a client asks to reach some of these pictures, your Nginx, your web server or whatever is configured to search in your memory space to serve that picture, for example, that data. And yeah, it is faster, then your response will be transmitted very faster, so it decrease your response time and increase your performance. And here at this example, your main memory, your RAM, is kinda cache. And in another example, imagine that you have a graphic card and it is responsible to doing some graphic thingies in your system. Then it has a cache which is faster than your disk or whatever. Then yeah, it used this cache storage to increase the performance, the speed of processing. Or in another example, imagine that you have a storage layer like Ceph, and you have your HDD layer as your storage behind your Ceph, for example, and you faced with some performance issues in read operations. Then you put some SSD disk on your cluster, on your nodes, and configure this layer as a cache tier, for example. Then you may increase your performance on read, but I mean, why I am saying may, because it depends. In all the times, in all cases, cache could not be a good solution. It depends, but yeah, this is the use case of cache. So at this example, you configured your SSDs because they are more faster than HDDs as a cache layer. Then you increase your performance. Okay. Or in another example, you have your CPU here, and also your CPU has cache. This is a hardware cache on your CPU, and here you have your memory, your RAM, and of course this is more faster than RAM, and CPU use it to, for example, do some fast operations to store some metadata or some variables inside, and then it is more faster than memory. Then your process will be more faster, and this is cache. So caches are in everywhere. We have another metric related to cache, which is heat rate. Is the rate of heating data. I mean the times that you are reaching data per second, for example. For example, imagine that you are serving one of these pictures, and the heat rate of this picture is, for example, 35 per second. Okay, it means that the clients want to reach this picture 35 times per second, and this is the average hit rate of the data. And based on this hit rate, we have three type of caches. The cold cache, okay, at this cache, the hit rate of the data is near zero. And yeah, it means that we will store some data in cold cache, which they are not needed too much, and the hit rate is zero, near zero or zero. We have a hot cache, exactly opposite of the cold. The hit rate is 100%, or I mean near 100. That means that this data will be needed too much times, and you need to have it in your cache all the time because it needs. And between them, hot and cold, we had warm cache. It's not 100% needed, and it's not zero, I mean the heat rate. So it's warm. And we are done here with this chapter. Let me back to the first slide to see what we talked about at this episode. We talked about these topics. The concepts chapter is over. We talked about some main and important metrics like utilization, load, Iops, throughput, bandwidth, response time, latency, workload, and cache. So, as I told at the beginning of this episode, we are done with the concepts chapter. And after this episode, we will have more interaction with operating system and also inside Linux command line. So if you liked it, don't forget to subscribe, like, and also share with your friends. Till next episode, bye!